Hello, everybody. Welcome to part two. Okay, so the first thing I was trying to do was I was trying to ping our outside interface of the VPN ASA. So I was pinging 65.10.10.20. That's what we gave it, and I can't ping it. So, huh, I was trying to figure out why that was, and I was thinking maybe it's a access list, but really the access list that you put on the outside is only for ping going through. So I finally figured it out. What it is that I don't have a route. I didn't have a route. I didn't create a route back to the internet. So the traffic was going all the way over, getting to here, but it couldn't get back. So on the VPN ASA, we need a route. We need a default route. So let's do that. Make sure that works. So route outside, and this is going to be to the HSRP address. So route outside. So this is going to be all the traffic, default route. We're just going to do a default to 65.10.10.1. And that should do it. So now you see the ping works. So, okay. So that was a little bit of troubleshooting I had to do between videos. Okay, so now let's get on to creating this VPN. What we're going to do is we're going to do an IKE2 VPN connection between these ASAs. So let's start configuring let's do the VPN ASA over here at the headquarters. So VPN ASA, good, okay. So the first thing, I think if we do, let me actually get on the right one. So show crypto Ike v2. Ike v2 SA. So there's nothing created here. So let's do this. Crypto Ike v2 enable. So we're going to enable it on the outside. And still, it doesn't show us anything there. Okay, so let's take a look. So next thing we're going to do, let's create objects. So object, network, and it's going to be HQ, the headquarters subnet. And the subnet for the headquarters is 10.150.0.0, and it's a /16. And then let's create the subnet for the branch, or the object for the branch. Network branch subnet. And this will be subnet 10.160.10.0, 255.255.255.0. Okay, we've got the two objects. Let's exit out of there. So now what we'll create is the interesting traffic access list. So this is what tells, and this is a policy-based VPN. We'll also go into route-based VPNs, which are more modern, and you probably want to use a route-based VPN. But these are still widely used, policy-based, especially with Cisco, because I believe Cisco started supporting it in ASA 9.7 or 9.8, something like that. So ACL branch, do line 1, even though there is only one, extend it, permit IP object HQ SN to object branch. And case matters here, spelling matters here, obviously. Okay, so we've got the access list there, that interesting traffic. Now we're going to do the NAT exemption. So inside to outside. So source static HQ SN, and we static it on itself so it stays the same address. Destination static branch subnet, and again static on itself. And we're going to do no, let's see, we want to do no proxy ARP. So no proxy ARP and route lookup. Okay. So now we've created the NAT. So now we're going to start creating the tunnel. So this will be tunnel group .70.10.10.2. We're going to say the type. The type is IPsec L2L. Tunnel group .70.10.10.2, and this is going to be our IPsec attributes, and then it'll go to another level, and we will enter. This is going to be where we put in the shared secret. So for IKE v2, we have remote authentication. We're going to do pre-shared key. And it will give you the warning that you must create a local authentication also. So that's a good reminder that you want to do IKE local, IKE, let's do that right, v2 local authentication, pre-shared key. And again, we're going to use the same one, and I don't see why you would not use the exact same one. So super secret 1. And is a camp, keep alive, threshold 10, retry 2. Okay. So there we've configured the tunnel group. So now let's create the crypto IKE v2 policy. So crypto IKE v2 policy, we're going to give it a number. Encryption, and let's see what we have for encryption. So we're going to use AES 256. Now, it just has to match on the other side. So if you're doing this with another vendor, you just have to make sure that you get something that matches, that both vendors can handle. So encryption, so we have encryption there. Integrity. And let's take a look at what the options are. We'll use SHA 256. Group, the Diffie-Hellman group. And so we're going to use Diffie-Hellman group 19. You can see there's some that are deprecated. 2 is deprecated. 5 also deprecated. So group 19. PRF, SHA, let's take a look. SHA 256. And lifetime seconds 86,400. All right, so that's the crypto policy. That's phase 1 policy. So now crypto IPsec. This is going to be the phase 2 part. IKE v2 IPsec proposal, and we'll call it VPN transform. You name this whatever you want. And this will be protocol ESP encryption. Again, you have a bunch of choices here. Just make sure they match on both sides. That's the important part. AES 256 we'll use. Protocol ESP integrity. And we'll use SHA 1. Okay. So that is the proposal. So now we're going to tie it all together here. All right. So let's exit, do crypto, and this will be the crypto map. This maps everything together. VPN, we're going to call it VPN. You can call it, really this is just, and I'll show you here, just a name. And you're going to assign that name to the outside interface. But crypto map VPN, you're going to give it a number, sequence. So this will be 1, match address. So this is where we're telling it what the interesting traffic. So if you remember that, we set up a access list and we called it ACL_branch. So that's our interesting traffic. Crypto map VPN 1 set PFS. And this will be group 19. Crypto map VPN 1 set peer, and this is going to tell us the peer, which is 70.10.10.2. So this is where the outside interface that we're connecting to. On the other side, crypto map VPN 1 set, set IKE v2 IPsec proposal. This is where we set that proposal that we created just a moment ago. And then we put the crypto map on the outside interface. And that's the configuration for VPN ASA1. So let's write that. And in the next video, we'll do the configuration on branch ASA1 and make sure everything's working. Thank you.